Morning, everyone. Let's get started. Yesterday, we were talking about simplifying the expressions you get, right? So we were at 45A, basic 45A, and basic 45B. You see similar questions. And I mentioned that these questions are possibly, okay, very likely to be your homeworks as part of your homeworks when you're in Calculus 1. So I hope you guys will spend some time to practice. And we, on the other hand, in the class, we can only do so much, okay? But we're going to do a little bit more today. We're going to do a little bit more today, and then we're going to move forward. We're going to move forward. Do you have any questions from your side? To reduce these expressions, and it is really a matter of familiarity and practice. Okay, we have the basics, and we address the relationship between what you are about to do in calculus classes and what you are going to what we have learned since beginning algebra and intermediate algebras and these algebra classes, right? And those things you learn there, they could blossom into other more complicated situations, but the basic principles and the basic practices are the same, essentially. Okay, so that if you don't have any questions, well, you can ask me anytime. I would like to take you guys to these expressions in basic 46A. Okay, and I can safely tell you I prepared all of these questions out of your calculus textbook and after taken derivative. Okay, so I took the derivative, and then we're just going to reduce it, and you have to be able to reduce it properly in order to get to the next step. Okay, so that's the situation. Excuse me. So let's get started with the first one. But here we have 3 tasks. Okay, we have 3 tasks, A, B, C, as you see at 46A. Okay, you need to simplify that expression, and you also need to solve you will create an equation, which is B, and then you're going to identify X value such that G of X is undefined. Okay. For G of X here, in the first question, number 1, this question looks very simple, isn't it? It's X raised to the power of -1/3 minus X raised to the power of 5/3. I actually have a story about this question. I took this question from a professor. I just happened to see his exam to his student who teaches at a 4-year school. And to our surprises, and I thought that his student at 4-year schools, they don't seem to have enough, their algebra don't seem to be strong enough to handle the situation to simplify that. Some of the students did it, did a simplification correctly, and some other student, on the other hand, just made a mess. okay? So, and with his permission, I said, okay, I'm going to use that question for my student, but I'm going to have them practice first. Okay, practice first. And if you look at 46A, right, if you look at 46A, and I have question number 1, 2, 3, 4, 5, and to the left, I have a little hint, kind of, you can call it a hint, right? It's might be the algebraic, okay, maybe the algebraic level of abstracted form, a simpler form in other words, okay, and hope that will help you to identify, to figure out how you would simplify this, okay. So without further ado, do you guys want to try this first? Excuse me. Shall we get started? We have get started, but I want you guys to have a head start. With what we did yesterday. Okay, I'm still working on your quiz, your first quiz this week. Okay, it will be related to lectures this week. And what are we doing this week? I want to give you a couple minutes to work on this. Do you guys know what to do? Do you know what to do? Just simplify. Why? This is an expression. This is a statement. This is not an if statement. Okay. Okay. If you look at the 3 questions, A, B, C, the first question asks you to simplify. It's not an if statement. It's just a statement. The second one, you create an if. We create an if statement. Okay. And the third one, of course, is actually identify the domain. Okay, identify the domain and what's not in the domain. Okay, what's not in the domain. So we want to simplify this. And the goal of simplifying this, then you say, well, isn't this look simple enough? No, we don't view this as simple enough. We want factored form. Okay, we want factored form. Okay, we want factored form. We want factored form. What is a factored form? Factored form is basically you have multiplication and division. You have factors. For example, this we know that, say for example, you have A times B over C. That's a factored form. Okay, and for a factored form could be like A times B. That's factored form as well. So all of these are factored form. Okay, such as. Okay, I want you guys to have a head start. I'm just going to refill my cup. Okay, I'm refill my cup with a cup of tea. And I will be right back. Okay, get started. Okay, you're gonna have 2 minutes. 2 minutes. And there's no pressure whatsoever. Okay, make a mess if you will. That's okay. Make mistakes. And feel confused, feel, don't know what to do. But because before the end of this today, you will know what to do. That's most important, isn't it? Right? All right, so I'll be right back. All right, I'm back. Anybody want to show me something? Be brave. Okay, I want you to understand. And I'm here to help you. Okay, if you show me your work and I can point it out, certain things you've done right, certain things you've done incorrectly, and that might be a more effective way to help you. And I understand it takes some courage to show your work in front of everyone, right? But who doesn't make mistakes, right? Who doesn't make mistakes? Who has never made a mistake, right? Who doesn't need to learn? Even I need to learn, right? What do I know? I just, I just learned this some decades before you because I'm older, right? So I'm not any more, smarter than anybody else. It's because I've seen these before you, right? So I can share my experience, and you can get these in no time. Do you want to share, or you want me to go for it? No? Yes? Okay. I'm going to just first of all, I want to make that connection, and I will start from the b to the power of -1. So I'm going to show you how I created that form. Right? How is this form turned into the other form to the left of the question, right? How did it turn into that? And this shows you the mathematical abstraction, right? This shows you the mathematical abstraction. Of course, this is one way to see it. So what I see is that I will rewrite this as x raised to the power of a third, right? And then I will multiply the exponent. And the other expression, I write it as the same base, right? So that's raised to the power of 5. That's one way to see it. So what's been done here, okay, so my b is really just the b raised to the power -1, right? Minus b raised to the power of 5. You see that? Where my b is equal to that guy. Right? So this process is called, you can call it a symbolic operation or mathematics abstraction. It's really some kind of substitution, isn't it? It's really some kind of substitution. And we want it to be in factor form. Okay, well, we don't think this is simple enough. Why factor form? I keep asking you, why factor form? Why factor form? Because we may be able to apply principle number 5, principle number 6, right? So those principles guide our steps, principles guiding steps. Okay, anyway, so how would we simplify this form, right? Well, we need to understand this is just 1 over b minus b to the power of 5. Okay. And finding common denominator. Okay, finding common denominator. So you have a b here and you have a b to the power 6. So in the end, we're closer to that quotient form. We're closer to that quotient, factor form. I call them factor form in general. Okay, and then we have the quotient form, and then you'll be thinking about, how am I going to factor this guy, right? You're going to factor this guy. Yeah, can you factor that guy? How do you factor them? There's so many ways to factor them, right? You can see this as one raised, you can see this as b to the power 3 squared. These are all actually very basic mathematics. You see the whole process I'm showing you this, you can see how basic these are. Okay, they just look a little weird from what you learned before, right? But if you take a closer look, and you totally know what kind of situation you're in. So this is going to be, so this is basically the form of what? It's a squared minus b squared. Oh, sorry, b squared. Right? We know how to factor that, don't we? Right? We know how to factor that, which is a plus b times a minus b, right? There you go. So in this factored form, you will have 1 plus b raised to the power 3 and 1 minus b raised to the power 3. In the whole process, of course, you can keep going. You can factor these, okay? Do you see these steps are basically elementary algebra? All right? And you can totally do it. I'm sure you can keep going. You can keep going. Okay, but we're not going to keep going. We're going to go back here. Okay, we're going to go back here. So if you see that, if you can see the basics aspect of it, that's what I wish you to see. Okay, and you can do it. Okay, so what I would do is I'm going to show you 2 different ways of doing this. Okay, I'm going to show you 2 different ways of doing this. Okay, if you've gone through these steps, and then you understand the 2 basic ways we're about to do. The one way is that you're going to write this as the form that we are familiar with. Okay, √3 of x. And this other one is x raised to the power of what? 5/3, right? So you're going to write it in the same familiar form. This is more familiar, right? This is more familiar. And of course, from here, you know that the x cannot be 0. If x is 0, you get a 0 denominator. In your mind, even though this little thing, it looks like, what a nuisance, right? What a nuisance. It's just a b. It's just a b. Okay, it's another symbol. You just treat it as one identity. It just treat these as an entity, okay, an object, right? In your programming classes, you're gonna learn object-oriented programming and that sort of thing. They are an object, a chip, right? Mathematical ideas turn into objects, objects turn into chips, which installed in our physical cell phones or whatever, computers and so on and so forth, right? You see, ideas turn into real thing, all right? So I'm not going to elaborate too much about these. So in the process, you can see the abstraction. You see the abstraction, you see the simplicity of it. But then you start to see the simplicity, okay? So now, like what I did here, I'm going to find common denominator. Okay, I'm going to find common denominator. So this is my common denominator. Okay, so that part doesn't change. And this other part, I'm going to get the common denominator. So I multiply by 1. And this, you know, this is a good, oh, oops. Okay, so I multiply the top and bottom by the same number. So that's equal, that multiplied by 1. Okay, and then we have the same denominator. Essentially, if we rewrite this piece, if you rewrite that piece, you have the same denominator, and this factor multiplied this factor, it will turn into power 6, right? It's a power 6. Do you see that? Equals to and now we have the same denominator. And then 1 minus the other numerator. What does that equal to? What does that equal to? We know some of the familiar forms, right? We know some of the familiar forms. For example, we know that square root of x, parentheses, squared equals what? Equals to x, right? How about the cubic root of x? Root 3 raised to the power of 3. What does that equal to? It equals to x. And these two has a domain issue. So this domain is x is larger than equals to 0. And this is any real number. Okay, because the domain of cubic root of x, this is one of the functions we have in basic one table. Okay, check it out. And the domain is any real number. This is true for any real number. This is true for any real number. Now you have a to the power 6. To the power 6 can be seen as what? To the power 3, to the power 2. Is that right? So what do we get here? This guy. Huh?
Would it be x squared?
That's right. So now here is x squared. Isn't that look simpler? Much simpler, right? Okay. And then what? Cubic root of x and the top, can you factor that? This is the factor form we're talking about. Okay, this is the factor form we're talking about. You have simple factors. Do you follow me? Do you want to try that all by yourself? Okay, I'm sure you can do it. Okay, so this is one way to do it. I will show you another way to do it. But before I show you another way to do it, I want you guys to go through the steps by yourself. Okay, I'm watching you and I'm not watching you. I'm not going to watch you. Okay, I'm going to give you a couple minutes for you to redo the steps on your paper. Would you do that for me? Do you want to try it? No judgment. Only practice. Only practice. Only to get better. Okay. Guess what? And I told you I steal this question from a professor who taught at four-year school. When he was disappointed, obviously, at his students' performance, and he said, I thought I gave them an easy question. You see, that's the mental state of your professors in college, in four-year schools. They thought they give you an easy question. Right? It did look pretty simple. Right? And then you can see it requires just some basic algebra stuff. Really just requires some basic algebra stuff. So what I'm going to do is I'm going to give you a couple minutes. I'm going to turn off the video and turn off the sound, and I give you the time for you to practice. Do you think I should stop the share? Or you can discipline yourself just not looking at it? Could you do that? You don't do, because I trust you guys, right? This is no judgment, just to practice. No judgment, just practice. Okay, so I'm going to leave the screen on, and you try to discipline yourself. Don't look. Okay, and then I'll come back in a couple minutes. What did it go? How's it going? Is it getting easier? You're doing it, right? You're doing it. And you can see through these practices, you are getting better. You are definitely getting better. Okay. All right, so let's move forward. I promise you, I'm going to show you another way to do it, working with exponents. I also like to give you some rule of thumb. Okay, a few, just a rule of thumb that usually works pretty well. Okay, usually works pretty well. And you're gonna see like sometimes it's power third, power half, and power 1/5, and they're all similar. Okay, you might see one of those situations. Okay, what you do, I showed you this yesterday, but it was at the end of the class, so it might be kind of rushed. When you see negative exponents, usually you factor that piece out. You factor that piece out, okay? Then you say, how do I factor this? I can factor this piece out, but this piece doesn't have it, right? This piece doesn't have it. So this method works directly with the exponents, And the tool you're using are really pretty basic, right? I pointed out yesterday. Okay, I pointed out yesterday. Okay, pretty basic tools. Okay, I would say put an omega there, right? Where you put an omega there, where you put some, whatever. Something like that, right? You see, it's a pretty basic tool. It's a pretty basic tool. So you factor this piece out. Okay, you factor this piece out. Then you say, hey, I don't have it, right? That's okay. You can make it by multiplying by 1. Okay, so x, this will make it. Because if you combine these two, you're gonna get a x raised to the power of a -3rd multiply x to the power of 1/3, right? So -3rd plus +3rd, that's gonna make, basically what you're creating is something like that. Okay, here. 1/3. Okay, and this is really what? This is x raised to the power 0, right? X raised to the power 0 is 0. I'm sorry, x raised to the power 0 is 1, because x is not 0. So we're using this property, this piece. Do you follow me? So just like creating 1, there's all these different ways of creating 1. Okay, so something raised to the power 0 is also 1, right? So we know one way to create 1, right? So let's put a little summary here. Creating 1 is equals to something over something else, over the same thing. It is also equals to something raised to the power 0, provided that omega is not 0. So these are the ways to creating 1. These are the two pretty common ways to creating 1, right? We see this technique being used in rationalization, rationalizing numerator, denominator, but here you can also work with this form. Do you guys follow me? Okay, and with that said and done, we can just, that's how we split it, right? These two into x raised to the power of 3rd. So that way you can factor this out. But this intermediate step usually is not shown. I would declare in any textbook, they don't show it that step. They don't show that step to you. You're supposed to figure this out. Okay, what they will show you, this is what they're gonna show you, okay? This is factored out. I'm sorry, here. This is factored out, and then you're just gonna see 1 minus x squared. A typical textbook will just write it this way. If you see such things, similar things done in a textbook, that's usually what they show you. Okay, because a textbook, they cannot afford to show you every little details. So you and we are supposed to fill in the gap. You will wonder, how did it get from here to there? Well, for the people who write the textbook, or for the professor I just mentioned, who was giving these exams, in their mind, this is pretty straightforward. You're supposed to know. Do you follow me? That's their mental state. That's their expectation. That's what I'm trying to tell you, right? We live at different levels of expectations, or what we can do, what we cannot do. But there's certain expectations that comes with it when you're taking classes. Okay, and so that step is here. Do you follow me? And of course, there's much more to it, right? There's something to the power 0, and so that's being used. Is this forms simpler? Yes, I agree. I think working with these steps, of course, is our familiar form, but we need to be willing to step into something a little bit different. And guess what? You're going to get familiar with it very quickly. You will, because I know you will. Right? And so the situation could be one, it could be the fifth power, it could be the fourth power, second power, and so on and so forth. Right? And by this time, you can bring this in. You can bring this in. Or you can keep it that way. You can keep it that way. Okay, you can keep it that way. You can say, oh, I'm going to just keep this guy over here, and I'm going to keep it that way. That's the factor form. Do you guys see that? So it could be this form, it could be that form. The same thing. They're the same thing. All right, so we did the first step, right? Whichever way you like. Whichever way you like. But I urge you guys to be able to practice so that you can do either way. That'll be the best. Okay, if you say, oh, well, I really prefer a certain way, that's okay too. You just do the way that you feel most comfortable. Okay, and then gradually going out of that comfort zone and maybe try something new. Okay, this will tremendously enhance your algebraic skill, will give you more ease when you're taking calculus classes, because you're going to have, many theorems to work with, okay, those theories to work with. But anyway, without further ado, let's look at the next step, okay? So the first step, A, right, we just simplify. So we have simplified a G. We have simplified a G, right? So I'm going to put the notes over here. And that's our A. The second step, I said, you're going to create an if statement. We're going to create an if statement. Okay, so this is A. And next, we're going to create a an if statement. Creating an if statement, right? We know that G is, oops. We know G is equals to G is a function, and that function, whichever form you like, right? If you like this form, which I believe most of you do, I could be wrong, okay? Because this form is what we are most familiar with, right? We're gonna say if g of x is 0, right? Because find x value such that g of x is 0. So it's you're creating an if statement. That's what it is, right? If the output is 0, right? We've been very familiar with that language, right? Input, output. We're gonna solve for x. We're gonna solve for x. And obviously x cannot be 0. X cannot be 0. You can keep this form, you can keep the factor form, you can also keep it this form, whichever one you like, really. Because at this point, you are, you're ready to go anywhere, But anyway, without further ado, and from this creation of the if statement, and say if is equals 0, what happened? Denominator cannot be 0. Denominator can never be 0, right? So this is in the place of denominator. So what must be 0? Well, this has to be 0, right? This has to be 0, right? Or you can say, oh, you can say that. You don't have to do both, right? Or this guy is 0. Right? Then you solve for x, what you get? X is equals to what? Plus minus 1. Right? So I would agree with that professor from whom I stole the question. I can see this is actually, he really didn't mean to make it difficult for his students. But the key step is what? What is the key step? The key step that you need to be able to do that basic algebra thing correctly. If you made a mess there, most of the points is gone. Most of the points are gone. Okay, so we need to be stronger with our algebraic skill. Okay, but anyway, without further ado, from that step to the next step, we have learned different techniques, right? You can do it by x squared equals 1 on both sides and taking square root and all of that stuff. I'm not going to repeat. Or we learn the way of this is principle number 5. It's very straightforward, right? Okay, so the third step, C. Find the values that G is undefined, right? So since this is a G and this is a G, right? This is a G. Where is G undefined? Where G is undefined. Well, the numerator is a polynomial. It's a quadratic, in fact. The denominator is a cubic root. The cubic root is defined everywhere. Domain is all real numbers, but because the cubic root is in the denominator, it cannot be 0. So then the number that x cannot, where x is undefined, is x equals 0. Okay. And then you're done. So this is the ABC 3 steps. 3 steps. Do these 3 steps have significant has a lot of significance in your calculus 1 class. Chapter 4. I'm telling you, it's in chapter 4. Right? The only thing I skip is taking derivative. After you've taken derivative, that's what you get, and you need to be able to do performing the algebra, and so on and so forth. You got it? If we got that, let's try something else. Let's try number 2. Are you ready? Are we ready for number 2? Okay, and you can see none of these questions actually even touched trig functions or exponential function. There's just very basic functions. Okay, even if you don't take calculus 1, math 190, you take math 165, right? If you change your mind to go to, the business track, or you guys know what I meant, right? 165 is a course people who don't go to STEM. Even you go that track, these practices will also be helpful for you. Okay, because for 165, they don't use anything trig or exponential. They use a little bit of exponential. They definitely don't use trig. If you don't use trig and you learn calculus classes, what do you use? You'll be using these functions, right? Polynomials and root functions and rational functions and so on and so forth, right? So this will also be helpful for you, okay, in case you change your mind about your major. But anyway, keep on practicing. Number 2. Okay, number 2. We have g of x is equal to 2 minus x squared minus x squared that. Still 3 tasks, A, B, C. Simplify. Simplify meaning you're going to get to the factor form. I used to tell my students who were taking calculus classes and then didn't make it. Okay. And what I recommended is that if you don't make it through your calculus class, if you didn't make it, you take your calculus class, you didn't make it, you should not take calculus class again. Not yet. You should go back to review your elementary algebra, trigonometry, those stuff, and then come back to take it again. Okay, because if you simply repeat those, you simply repeat that class 1, 2, 3, 4 times, it's not going to help you very much if you don't work on the algebra part. Okay, I feel that's an honest recommendation from my conscience. Okay, it's not I have any grudges against anybody. It's just it probably just make it more efficient for you time-wise. Because most of the cases I see our students lacking is the basic algebra part. Okay. Anyway, so that's why I yesterday I urge you guys, so please, after the semester ends, don't stop practicing. Keep practicing. Okay, these exercises, it will serve you. All right. So with what we just did, I think you can handle this. So maybe, do you think I might be able to see your work? Would you like to contribute? No fear, because at the end of the class, you will be better. Before the end of the semester, you will be better. You'll be even better if you keep on the task.
I tried doing the beginning. I'll send you my part.
That's great. Yes. Yeah. Because don't forget, I'm here to help you. Right? I'm here to help you to better prepare for that calculus class. Right? So if you take the initiative to let me know more about you, and then I hope that I will be able to help you with, more efficiency. And these are realistically, actually, your calculus class questions with some steps. Skip. Okay, I see Andy's message. Okay, let me check on that. Thank you very much for sharing. Okay. Hold on. There, very nice. Okay, let me download that. I'm gonna share. Thank you, Andy. All right. First of all, before I check on the steps, you can see he shows his work very clearly. Very clearly. That's very important. Okay, that's excellent. Very well organized. Right? Each line is separated with the other line. There's space in between. I think that's beautiful. That's beautiful. Okay, then we dive into the steps. We dive into the steps. Okay, so now I'm going to check on the steps, right? That's good. Okay, the first thing I check, I would say, is each equal sign properly placed and are they validated? So these are the questions I have. When I grade your work. Hold on, what did I do? All these. Do you guys see the question? Do you guys see it? Yeah? Yeah, I'm checking the work. I should see these. I have this the advertisement, but anyway. Please get out. So I close my email. Close my email. Let's stop. Okay. Sorry about that. Okay, so first thing I check if you copy the question correctly, right? You copy the question correctly. So did you copy the question correctly? Everybody check it for me. Right? Everybody check it. Oh my God. All right. Do you guys see the ad that come to my screen or you don't? Okay.
It's just the sound.
Oh, it's so annoying. All right, so what do we see here is that you see he makes the common denominator, right? So I'm going to start grading over here. That's good. That's good. The equal sign is justified. And that's the next step. He did it correctly. Over here, that's good. And factored. That's perfect. That's perfect. Do you agree with me? You did a great job. Okay, great job. Thank you, Andy, for sharing that. Okay, that's wonderful. And you always write your work nicely. Whoever is a teacher, Okay, by doing that, you're already getting points. You're already getting points. Okay, you're already getting points. All right, so without further ado, very, very good job. Now, do you guys want to write it down? And you can, this is literally the same work I would have done. Right? And at the end of it, what did you get? You're getting better. You're getting better. Your algebra is getting better. You know, and you can handle these with ease. And you can't help it. You're going to get lots of points. Okay, you're going to get lots of points. All right. Excuse me. All right. So if you write that down, so from this step, okay, I'm just going to work on his question then. When we create that equation, right, the second step B, if g of x is 0, what are we getting? Same question, same answer, right? If g of x equals 0, denominator cannot be 0, so the numerator must be 0, right? So let's proceed, right? If g of x is 0, then what? It's just 1 minus x squared is going to be 0. Okay, so as the result, x equals to +1 or -1. Right? And you're done with B. And C, what is C? C is identify the values that the numerator, the function is undefined. Okay, the function is undefined. You can see that in this case, basically you determine the domain. You determine the domain. What is the domain of G? You can start with the original equation. You know what? I did find a little bit flaw in your work, Andy. Okay, I'm sorry I overlooked. If I were you, I'll make this just a little bit longer. You guys see that? Did you see that? Yeah? Andy and everybody else, make this just a little bit longer because it should be that way. Things like this will not escape my eyes and will not escape other people's eyes. I might take a point off for that because it's different. Because it's different if you don't have that long enough. If you don't have that long enough, it would be like √2 minus x squared versus √2 minus x squared all together underneath the square root, right? That's very minor, okay? I'm sure you can correct that in no time. So now what number that will, I'm going to change back to the screen, okay? Clear all drawings. And share, let's go back here. Okay. The place that g of x is undefined, right? Typically, if this is 0, right? It cannot be 0, right? It cannot be 0. So so how do you set up that domain thing? Okay. So we have the answer simplified. So I'm just going to copy his answer right here, right? Whichever form you like. So this is going to be 2 times 1 minus x squared, right? And we're answering the question for C, right? We're answering the question for C. To determine the domain, you just have to set up 2 minus x squared has to be larger than 0. Okay, all the other values is where G is undefined. Okay, so first you basically determine the domain of G. Okay, you want to tell the reader, give them some kind of guide to for them to read your work, right? We determine the domain of G, and then what? Then you have x squared less than 2. And then you have absolute value of x less than square root of 2. Okay, and so in the end, you have a negative square root of 2 less than x less than square root of 2. But we need to indicate the numbers that are, the G is undefined, right? This is where G is defined. Do you follow me? So you're gonna say values where G is undefined. Undefined. Defined. Spell it. Okay, what are the values is G is undefined? Well, it will be the opposite of it, right? So that would be the opposite of that. So what's the opposite of less than? Is greater than or equal. Values where G is undefined. Okay, that is, i.e., that would be x less than equals to negative root 2. In your calculus class, there will be other explanations. Okay, there will be other stuff because of the way the question we ask here. So you be careful when you're in calculus class. You need to be careful about how the question is asked. Okay, you're going to learn new concepts, and so that's something I'm not going to get into. But for the specific questions I have here asking you to identify the values that G is undefined, then you need to give me the answer. Do you follow me? So I answer to the question that was given. Okay, answer to the question that was given. So we did number 2. Do you feel you're getting better? You are getting better. Definitively. Okay. Would you like to try number 3? Or number 5, right? 3, 4, 5. 3, 4, 5. What I'm asking you guys to do, 3, 4, 5, you arbitrarily choose one question to do and submit. Would you like to try that? Okay, so 3, 4, 5, choose one. Well, if you finish early, you can do the next one. Choose one and work on it. Then submit. Love to see your work. Okay, you're gonna answer A, B, C though. A, B, C. Okay, A, B, C. Don't forget that rule of thumb I mentioned, okay? If you want to do the power rule, you do the power thing. The rule of thumb. Do we have classes on Monday? Is that a holiday? Let me check. Let me check the school calendar. Wait, I should have that in my syllabus. I should have checked. Right? Syllabus. Memorial Day. No class on Monday. No class on Monday. All right. Memorial Day is next week, so probably not. You're right, Gordon. Agreed. So there's no class on Monday. So what I would do is that I'm going to I'm going to set the due date of the quiz to be I'll set the due date of the quiz will be Monday. Just give you a little more time. Have some good time, right? Have some good time over this weekend. When you're done, you can submit. Okay, but I'm not rushing you. I want you to take your time. And if you have any questions in the process, feel free to ask.
I got stuck on number 3. Can I just like send in my work anyways?
Sure, of course.
Okay.
Okay, so let's do this. You're talking about number 3, right? Do you want to
Yeah.
submit a little bit, or you want me to just go for it?
Yeah, I submitted what I had.
Okay, let me see. I didn't hear the sound. Oh, there. Got it. Got it. Thank you. Thank you for the submission. Let's see. Wait. Come on, I didn't hear this sound. My cell phone responded, but oh, there, got it. And my computer seemed to be just a little bit behind. Now it's okay. Interesting. There's a little latency there, right? All right. First sight is nicely organized work. Okay, it's nicely organized work, right? The lines are clear, equal signs are lined up. Those are, the aesthetics we see right away. Okay, so now does everybody see the new screen? Right. So first we check is the question being copied correctly. Okay, that's something I always check. Okay, because if you copy the question incorrectly, you could have created a different question. So I have to grade it, with, somewhat different, but some points will be taken off right away for the copy error, But anyway, so 3, so that's good. Okay, so that's good, and that's good, and that's good. Okay, so he did the substitution, that's good, specified. And then he made the common denominator, right? And he get to this step. Get to this step. And then what do we do? Right? We might, well, the work is done. The work done is correct. Hold on. I think you're missing a square here. Did you? Did you miss a square here? I think there should be a little square here.
Yeah, I missed this one.
Right? But otherwise, it's a very good piece of work. Okay. Not factored yet. Not factored yet. So I'm going to take off from there. So I'm basically going to just repeat some of his steps, right? And we go from there. And then we're going to do the factoring. Did everybody write it down? You can write down from your cell phone, right? You can write it down from your cell phone. Okay, very good job. Very good job. Thank you, Bailey, for sharing. And so I'm going to go back to that screen, and this is number 3. This is number 3. Okay. So hold on, I'm going to bring that Word document in front of me. Okay. So G of X equals to 3 times X to the power of 3/2 minus 9x raised to the power of 1/2 plus 6 times x raised to the power of -1/2. Okay, all right. Okay, the way he did it, I'm going to just follow that idea. He did it. Okay, so x raised to the power of 1/2. Right, it's identifying that is very, very good. Okay, so minus 9 times that, right? And plus 6 times, I'm just going to follow what Bailey did. Okay, he did a good, very good job. Okay, to the power of a -1. Okay, to recognize that and going through these steps, he factored out the 3, right? He factored out the 3. So what he got, he has the b's. Okay, he has the b's. So b to the power 3 minus 9 to multiply b plus 6 b to the power -1. And he also specified in that step that b is equal to very good practice, very good practice. Okay, you specify, you introduce an intermediate variable, you specify it. All right, and next, what's been done, okay, is factoring out the 3, factoring out the b's, right? So over here, you're gonna have, you have the b to the power, do this, okay, just keep it that way. So he got b to the power 4 over b minus 3 to the power b squared over b. This is finding the common denominator, right? So that's the 2 over b. Oops, b, and that's a 2. Am I right? Okay. And then in the end, well, towards the end of his work, he has a b here, and he had the 3 here, and he has the, you can certainly write it this way. Okay, so my way of writing is slightly different from what his ways of writing, but they're the same thing. Okay, so how do we factor this? Right, you can, if you think of b squared as x, then you, well, xy, right? We already have an x, right? So, okay, hold on. I'm gonna put a little like notes here. Okay, if you look at this expression, this is actually a quadratic. This is actually a quadratic. Why this is a quadratic? If this is y, then this is y squared. Do you see that? And then you can factor. Then you can factor. Okay, so I wish you guys to know that when these authors or professors, they created their questions, and sometimes they do try to make it a little bit easier so you can use your techniques, the techniques you learn, especially for academic reasons, right? This is one of those typical examples that in the end, you actually will get the factors, right? You get the factors. So you have a 3 over b, and now you're gonna have b squared minus 1 multiply b squared minus 2. And of course you can factor further, right? Of course we can factor further. So what do we get? Any questions so far? Any questions so far? Of course we can factor even more, right? The b squared minus 1 is b squared is b plus 1 times b minus 1. Right? And b squared minus 2 can be written as b multiplies plus or minus square root of 2 the convenience of doing that, of doing this, right? And the other thing is that if you keep going like that, right? Just let me finish this, okay? I'm going to show you all the other stuff. If you keep going on this way, don't forget be this guy. Be this guy. Do you guys see that? So from here, if you notice that b squared is actually x, right? B squared is x. Then you don't want to go this far. You don't want to go this far. Do you follow me? You don't need to go this far. What happened is that you're going to just keep this root of x, square root of x. Oops, what am I doing? Right? And here it's just x. And then simplify it. We have, of course, we have all these substitutions. So let me show, oh, we're near the end of the class. So let me show you, once you're familiar with these, right? There's a lot of details, but in terms of showing work, you can totally do the following, okay? I'm gonna trim some of the work, okay? Suppose you've done all these work and this way or that, I'm sure there will be variations. What you can do, okay, what you can do, you can go, okay. I think it's about okay. It's all right. It's all right, but I'll keep talking about this tomorrow. Okay, I'm going to keep talking about this. Meanwhile, I would like you guys to explore. Okay, I want you guys to explore. I encourage you guys to explore in ways you feel comfortable or in ways you're not comfortable. And make mistakes is no big deal. Making mistakes is no big deal. Okay, so the show work part, I'm just going to remove this. Okay, I'm going to just show you. We will continue this tomorrow. And meanwhile, I want you guys to do 4 or 5 before you come to class, if that's possible. Okay, and we will continue on this. We'll continue on this. All right. Isn't that getting easier? Okay, we definitely can trim this, and there are 2 different ways you can do that again. But I'm glad, I think you got the hang of it. You already got the hang of it. Okay, the rest is just to have a little more practice, and then you'll be totally fluent. You'll be totally fluent. Okay, so I will see you guys tomorrow. Being aware that no class on Monday. So the quizzes, the due date for quizzes will be on Monday instead of Sunday. Okay, so I would just give you a little extra time. Okay, so see you tomorrow. I'll be heading to the office hours. If you want to come, you are more than welcome to come.